problem was the cause of the detachment on the end of the beaker. So what's the main cause of the detachment?
I've said before, it is due to collision and centrifugal force. So in the three part, I split the whole process into three parts.
Okay, I have
centrifugal force and collision.
And what about the terminal velocity? When the hole comes out of the beaker, don't you believe that the gravitational force could keep exceeding this velocity?
Yes, this is from the energy term. This is the gravitational force.
Okay, but is this terminal velocity existent?
Yes.
So, is there any force equilibrium? So there is a terminal velocity.
Yes, this is a. Yeah, we have an equilibrium force.
Okay, thank you. And the up-down beads that is shown there.
Yeah.
Okay. How the impulse in the beads influence the height that it reaches over time?
So, what? I'm sorry, pardon?
The impulse in the beads.
Yeah.
How does it influence your phenomenon?
Well, this is just the additional slide. What is the main part of my slide is the flying state.
Okay, but what's the influence of the impulse in the beads? Just tell me briefly.
So okay, the waving bead. So we
Okay, in the arrangement of the beads inside the beaker, you try to analyze the shape of the detachments and how the arrangement.
No, I'm not trying to. What? I'm sorry.
The shape of the.
Yeah, I'm trying to.
Okay, but does the arrangement inside the beaker influence something? The
yes.
arrangement of the chain.
So there is.
So good morning everyone. My name is Barbara and I'm going to present the acquisition for team of Brazil of problem number 3 single feet. So first I'd like to make a summary of their presentation. In their theory they basically talked about the flying state and the collisions with the walls of the beaker. And in the experiment they basically talked about the terminal velocity and the conclusion was basically about it also. I'd like to show some positive and negative points of their theoretical model. They're trying to make some qualitative explanation, trying to make some mathematical model, although I want to question about the validity of their mathematical model. They try to describe the detachment, although I want to talk about that later in my discussion as well. The negative points, they didn't talk about the acceleration behavior as during the motion as the mass is varying and while the beads are touching the floor as well. They didn't talk about the minimal energy, and the problem asks us, there is a sufficiently long part of the chain to be pulled for the motion to initiate. They didn't talk about the position of the center of mass of this part that is being pulled to define this minimal energy. The impulse of the beads that, in our opinion, it's really important for the involvement of the detachment and function of the time. They didn't talk about this. The size and the distance between the beads would change the shape, the angle of the detachment wasn't evaluated. The arrangement of the string inside the beaker wasn't evaluated, and they tried to describe the shape of the detachment in their experiments, but this is not talked about. The transference of energy, like the dissipation by collision with the floor as well, is not talked about, and we do think that it could influence in the oscillations of the detachment in function of the time. And he defines a terminal velocity, and we do want to discuss about it. The positive points of their experiments, they basically showed us one video saying that the shape of the detachment couldn't be evaluated clearly. And they showed a graphic as well, but we want to discuss about this because of the errors. The negative points, they didn't evaluate some of the parameters they quoted they showed in their theoretical model. They didn't show in their theoretical model. The minimal energy, the height of the detachment in function of the time, how does it involve in function of the time? And what can you tell me about your experiment? The dissipations, there's no attempt of clear quantitative analysis despite of the graphic. The fit with your points in your tendency, clearly has some points out of that tendency within the deviation you showed us. And main parameters are not analyzed, and I want to discuss them while the discussion period. So thank you for your attention. First, let's start by determining velocity so we can finish the value.
Can you show the? Can we show this?
Just please, you have a chain here, okay? And it's coming out of the beaker. When the whole chain is out of the beaker, what's the force acting on the chain?
Oh well, we have normal force from the floor, the tension which is the what?
No.
What?
Okay.
Internal force and gravitational force.
So, do you believe that there is a terminal velocity?
Yes, I believe there
But the
is.
gravitational is an increasing velocity.
Well, actually, yes. It is true that we have the downward force, but you forget that we have the upward force in here.
Okay, but the normal force is in the whole chain?
Yes.
Isn't the whole chain? Okay.
Yes, it is just we assume this as a one system. We will see that there is a gravitational force and the normal force to create an equilibrium.
And what about the height of the detachment we're talking about the time? How does it oscillate and why does it oscillate?
Well, there is the oscillation. It is due to the we cannot have the supply with from the one point. We will have the ring will like this, right?
But
the detachment.
no, not inside the beaker. The flying
No,
state that you're talking
the flying states, but the supply of the bits in the flying states is still in here, right? So our supply is.
Okay, but now it increases with time. Does it oscillate? What happens with this kind of detachment above the edge of the beaker?
Yeah, that's why the head is oscillating because the source of our bits is oscillating.
Okay, I don't agree with your point.
Why you don't agree?
I wanted to ask you whether it increases with time, this height of detachment, and why? Because I just think that the impulse is increasing with the tension.
Sorry. Can we from the ship? I try to.
Before I get to my point about what is
Lebih laju, ship. Slide. So we have in here, if this move, the angle formed by the tension will change, right? It will affect the height of the.
Okay, but I do think that there is one more parameter that is influencing this oscillation. What about the collision with this one?
The collision with the floor.
Isn't it dissipating energy? So the mechanical wave of transference is smaller.
Back. So this is the energy loss, right? I have already said it that there is an energy loss
so
here by.
Doesn't this energy loss influence your height of detachment?
Yeah. No.
Well, I don't agree with your point. I do think that this is. Unfortunately, I don't agree with your point.
Why?
I do think that this collision.
You disagree with my model, so we will discuss it.
Yeah, I do think that the dissipation by the collision with the floor would influence the oscillations of the height of detachment.
Why? What is the physics?
Because
Why?
the mechanical wave that will be transferred to the rest of the chain will be smaller. The transfer to potential energy, so the height would be smaller. And what about the cause of the detachment? What's the main cause of the detachment?
Collision. So
collision. But if you had no collision with the floor, like you're 100 meters from the floor and you're releasing a string of 3 meters, what is the detachment occurs?
Collision within the edge, not within the floor.
Okay, but with the detachment, does it collide every single time with the
No,
beaker?
so I already split my system into 2 trees. In contact with edge, which is our which is the initial state, and there will be it's like up-down bits. So the bits, I have the velocity to jump.
Okay.
And also I have a velocity.
Sorry, I'm making another question. But isn't the tension occurring even if it isn't colliding with the beaker?
What? I'm sorry?
You have the tension of the string.
Yes.
Would it cause an impulse?
What?
An impulse.
Yeah. What impulse? What impulse?
The impulse. Force
Impulse
times
increase or increase where?
in the beads, in the string of beads, in the beads that's being pulled.
Yeah.
Okay. So wouldn't it be the main cause cause of this detachment, because I do believe that it is. Because even when you have the detachment, the beads are not always colliding with the...
I'm sorry, let me clarify this. So,
because you clearly have like this and not always, it's
okay,
not
okay, yeah,
always
you're right.
colliding,
You made the point. I will clarify. So, to trigger this detachment, first of all, I already said this. It has to exceed the velocity to jump, and we have the velocity to maintain its shape.
So the shape is always the same during the
No. I really like the point. So initially the beads will still in contact with the edge, right? And it's always collide until it gains.
Well, I don't agree with you. I do believe that the tension causes some impulse, and then you have the height of detachment. So let's talk about the experiments. Then we come back to then we come back to your theoretical model if we have some time. Can you show me that graphic you put in your slide? Okay. So you clearly have 2 points totally out of the tendency. Do you think that it's possible to use this tendency you're using?
Well, I have already mentioned it. My theory used the continuous rope, right? Meanwhile, my string of beads consists of
okay, what's
one.
So, as you talked about the continuous rope, whether you have like the beads wouldn't the size of the beads, the distance between them influence your problem.
Well, yes, but
yes,
I just made an assumption to.
And how?
And well.
What about it? Let's talk about the size first. What is the influence of the size of the beads?
Actually, the beads, which is like this, is just similar with the rope, which is have a continuous mass, but we have this separation tends to be 0. So
okay, what is the size of the beads? You had some R, that is the detachment, and so it changes the tension in your string.
No.
I don't agree with your point because I do think that there is a maximum angle of tension, and so you have the size of the beads influencing your tension, and so your detachment, and as well the distance between these beads would influence your maximum arc of tension, and so you have if you have a larger distance, you would have a lower tension, and so a lower height of detachment. So I do think that it is really important for your problem. Don't you agree with me?
Yes.
So about the linear rope usage, wouldn't the flexibility of it influence your experimental data or something? You use just a continuous rope, or you use the
No, this is actually my theory used the continuous rope, which is the velocity versus height must be fit on this. But I use this discrete mass on my string of beads. You know it. It fills in this point.
Okay, so you see that your mathematical model for the rope is not applicable to a string of beads.
No, not applicable. Well, this is much better. At least on conclusion.
Well, I do think
I can explain why the beads shape like this. It's
sorry, but I don't agree. And do you have a continuous shape here? You have the shape of the string that is fixed.
oh well. Sorry.
Do you have a fixed shape for the beads?
Fixed shape. Yes.
Always. But if you have like different arrangements inside the beaker,
yes.
if it's circular or if it is random,
yes.
the shape of the beads will be the same.
Tends to be like this. Tends to be like this. So this is the general profile of the string of beads, and well, if we apply it to the reality, we just add the randomness of from the container to that disturb our general
I don't
profile.
agree because you clearly see in your first video, if you could show us that you have some oscillations here.
Yes, because there is some randomness.
Oh,
you
so you do agree with me that the arrangement inside the beaker is important.
I've already said it.
Oh, so you said that the collisions were the most important parameter. And what about the dimensions of the beaker? Isn't it influencing your experiment? Because here you have some random patterns, and that shape that you told us.
It depends.
Clearly don't agree with your video.
If I have 1 meter of string and I just have a radius of 1 centimeter, the beads will feel into the whole container, right?
Can you come back to the plate again, please?
Okay.
Here you don't have a collision with the first part of the beaker, which invalidates your theory, don't you agree with me?
Right. This is already the flying state. This is already the flying state.
But the height is increasing. So why the height is increasing if it is not colliding? And you said the main cause of this detachment is a collision.
Well, I think I've already said it. I have upside beat while in the upside up-down beats. The beats will exceed. The beats already exceed the velocity to jump. So the beats will collide with the edge of the beaker and will try to.
So I don't see the point why the height of detachment increased by your theory.
Okay. After exceeds the velocity to jump, the force that maintains the shape of the beats is the centrifugal force.
Can you back your breath?
And centrifugal force is
okay. The discussion time is over, and your summary for the discussion.
Okay. First, I like to tell that I don't see the objectives of the problem totally solved, like the minimal energy that is sufficiently long part of the chain to be pulled. The behavior of the acceleration, I don't agree with most of their model, and also. The cause of the detachment, I don't agree that is the collision with the walls of the beaker. I think there's something more acting on that they didn't evaluate. Like the detachment, the tension of the string, it's really important for the problem. So their model for the continuous growth is not that applicable to all extreme cases, asymptotic cases that they can have, like larger beats, larger distances, smaller distances. Also, I think that the terminal velocity is not well defined for all cases when, like, you have the collision with the floor, or whether you don't have the collision with the floor, whether the gravity is acting after all the bits of something.
The reviewer, the time for questions. Good morning, ladies and gentlemen. I'm Tomáš Zahradník from Czech Republic, and I'm a reviewer to this task. Could you please switch on your presentation? I'd like to ask about the equation for the energy.
okay.
Could you once more explain how you get? Yes. One. Yeah, that's one.
For the energy law.
Yeah, for the energy loss, the dm velocity squared. So how did you get this equation?
Well, I have half of dm v squared. This is the kinetic energy. You know,
yes.
When a mass has a velocity, the energy is half mass v squared, right? So in here it has a half mv squared, and here it has a half mv squared. So the total is the mv squared.
And if you have, if the beats of string of beats don't touch the bottom, you know, so then this, what happened with this energy?
There is no terminal velocity, because what I assume this that our system has already in the steady state.
So you calculate this only for the case when the string of beats touch the bottom.
Yes.
Okay. Okay, and could you once more explain, probably use the force diagram, why actually the beats, string of beats turn down?
Okay. Well, actually, sorry. Well, okay. This is quite, I think, quite. There is a tension force in here, so changing back to direction.
Mm-hmm.
So the tension force.
Well, and how does it depend on the detachment, on the height, or why does the height differ?
So I'm sorry.
Differs.
Actually, the initial condition. So the flying state is independent of the initial the initial condition. So even if you have a velocity exceeds a velocity in here, you pull up the string to so the profile is always like this. So I'm sorry.
Okay, and Yeah, do you think that have you tried some different materials of string, and do you think that it has what is the influence of different parameters? I mean, for example,
Also, we just
the
have
elasticity, or
we just have one type of string.
okay. And what about the mass of beats? What's the influence? Or have you tried different beats? Have you tried different distance of beats?
Well, based on my theory, the mass of bits.
Have you tried?
Okay,
No, I
time's
just
up.
have one
Time's
type
up.
of bits.
Thank you.